This is our Festo Dynamics Mech Lab station, and this is specifically the stacking station. It has two 4-2-way valves which control both our double acting cylinder and our single acting cylinder. It works through the shutoff valve, which all the pneumatic air comes through, and it reads through these valve solenoids. We have the multi-pin plug distributor to read everything and give us our logic values, and then we talk through the computer using this easy port. We stack using these work pieces that will be pressed together using this single acting, and we also have this magnetic sensor in the back to tell when the double acting cylinder is behind or is fully retracted.
So the way this works is using a shutoff valve. This gives airflow through to its two 4-2-way valves. One has double solenoids to control a double acting cylinder, which is a piston controlled by airflow, and one has a single solenoid to control this single acting cylinder, which is another piston that's controlled by airflow. Now this piston pushes work pieces down the tube or down the track. This one compresses them together. Now over here we have a magnetic sensor. This is used to read or identify which position the double acting cylinder is on. Over here we have our multi-pin plug distributor. This distributes electricity towards all of the components. And it is our easy port, which is used to communicate with the computer and to download the code into it. Now this Mech Lab station, what we'll do is we'll load this plastic work pieces into the magazine. As they fall down, the cylinder will push them down the track onto the tray. This other cylinder is going to when two work pieces are stacked on top of each other, this cylinder will compress them together and fit them such as it would on any manufacturing plant. What you're seeing here is a simulation of the components of the Mech Lab station. The way this code works is using this logic module. It is the brains of the operation. On this other window, you can see inside of the logic module, we have a couple of logic gates. Now, what these do, they're sort of the code. These NOT gates, they reverse electric flow. These are just two delays that we have in series in order to make a sort of timer. Now, as soon as the code starts running, the NOT gates at the top and bottom will give out electric signals. The valve solenoids that controls the extended position of the single acting cylinder which press the two plastic pieces together, and the valve solenoid that controls the retracted position of the double acting cylinder, which pulls back the piston. After the piston has been pulled back, it allows for a new piece to fall down to the track, and the magnetic sensor will activate in the logic module. When the magnetic sensor is activated, it sends an electrical signal. Now what we see here is the magnetic sensor up here. As soon as that detects that the double acting cylinder has been retracted, it will send an electric signal through this wire into the first input. Inside, we can see that first input is connected to these two timers. This will give enough time for the double acting cylinder to retract and for the single acting cylinder to stop being actuated. Now, this is due in order to not have too much of a rushed operation, so we can avoid as many accidents as possible. Now, after it's been past 2 seconds, it's going to wait 2 seconds, and then here it's going to give out an electrical signal for 2 seconds. And when this is met, these two will retract, and this will stop being actuated, and the double acting cylinder will extend, pushing the workpiece onto the tray. Now, as soon as those 2 seconds are up, the electrical signal will stop being given to these NOT gates, meaning they will turn back on, It would slam down the single acting cylinder to compress the two plastic pieces together. It would actuate the solenoid that controls the retraction of the double acting cylinder in order to allow for another workpiece to fall down to the track.
Okay. So this is our flow chart for our Mechtronics stacking station. So first, to begin with, we load the workpiece into the magazine because we are trying to emulate a factory setting using the mech station. So we would have to keep doing this task over and over indefinitely. This means to maximize the efficiency, we will both have the single acting cylinder retract and the single or double acting cylinder retract and the single acting cylinder actuated at the same time. While the double acting cylinder retracts, the first workpiece will fall onto the track. As soon as the magnetic sensor is sensed, then the single acting cylinder will stop being actuated, which will retract it, and the double acting cylinder will then start to extend, pushing the first workpiece onto the stacking tray. As the double acting cylinder is then retracted again, it will stamp, but nothing will won't really happen until the second piece is eventually pushed onto the stacking tray. Then it will be compressed by the single acting cylinder, extending yet again, and it will make a compressed product that can be removed either by hand or pushed out of the tray using the next workpiece while the process just restarts.